The James Webb Telescope has just announced the clearest image of Proxima B in history, revealing astonishing details about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the mysteries of Proxima B and discover whether it could be the next Earth. Let's take off into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin, Proxima Centauri b, located a mere 42 light-years away from us. This planet is shrouded in mystery and wonder. Could it be another Earth with oceans and life teeming on its surface? But wait, there's more. Proxima Centauri b is not alone in its journey around the red dwarf star. It has a fellow traveler, Proxima Centauri c, and who knows what other secrets the star system holds. Perhaps there's another companion that we have yet to discover. The mysteries don't stop there. Proxima Centauri b receives just about the same amount of energy from its star as Earth does from the Sun. Could this mean that there's water on its surface? Perhaps even life? As we venture beyond our own solar system, we discover a whole new world of exoplanets. Planets that orbit stars other than the Sun. With 200 billion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even roam free, untethered to any star, like rogue travelers in space. But among them all, Proxima Centauri b stands out as a truly remarkable and enigmatic planet. With a year that lasts just 112 Earth days and a distance from its star that is 20 times closer than Earth is to the Sun, it is likely that one side of the planet is always bathed in daylight while the other side remains in perpetual darkness. Now let's talk about Proxima Centauri, the star that Proxima b orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A and Alpha Centauri b. Together, these stars create the nearest star system to our very own solar system. The two stars, Rigil Kentaurus and Alpha Centauri b, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation of Centaurus and are the third brightest stars in our night sky, with a peak magnitude of -2.7. Proxima Centauri, also known as Alpha Centauri c, is a red dwarf or M star located 21 light-years away from the other two stars. Approximately 13 times the distance between Earth and the Sun, it is technically the nearest star to us. In fact, Proxima Centauri translates to the nearest star in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri, despite being our nearest stellar neighbor, is not visible to the naked eye. It has an apparent magnitude of 11.13, which is far greater than the maximum human limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate a lot of energy, but the internal convection process at their core keeps them glowing for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still being debated. For one thing, it's a flare star, which means it has frequent and unpredictable fluctuations. As a low-mass star, the habitable zone would be closer to it than that of the Sun, projected to be between 0.23 and 54 cents. But it's not as habitable as it seems. Proxima b is bombarded by extreme ultraviolet radiation from its star, hundreds of times stronger than the radiation we get from our Sun. That's right. It's so intense that even the lightest molecules of hydrogen get destroyed, let alone nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima b might not have a suitable atmosphere, which is essential for regulating climate and supporting a water-friendly surface. Without it, living organisms will be vulnerable to space weather, making life nearly impossible. So while Proxima b may look like Earth on the surface, it's far from being able to support life. People have doubts. While there are numerous factors that render it unlivable, the quest to uncover the truth about Proxima b continues, and some people still have hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After numerous delays, the The telescope was finally launched in 2018 and will help us determine whether or not there is life on Proxima B. As with all things in science, things are never quite as straightforward as they seem. Many modifications were required to ensure that the James Webb Telescope produced accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of the planet and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere does not guarantee the presence of life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is 90 times denser than that of Earth's and extreme heat that would make it impossible for life to exist. The quest to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers are hard-pressed to find a way to observe planets like Proxima B. The risks are great, but the rewards are even greater. The chance to glimpse into the unknown, to uncover the secrets of a distant planet that holds the promise of life, is one that astronomers are willing to take. Traveling to Proxima B, let's say hypothetically, if the exoplanet were hospitable, could we even go there? It's the closest exoplanet to us, which makes it so exciting because it's almost like looking in our cosmic backyard. What's even more interesting is that it's roughly the same size as Earth, and its location in the habitable zone means it could potentially have the conditions for life as we know it. Proxima B's proximity also makes it a prime target for our search for life beyond Earth. And with it being just around the corner, well, relatively speaking, it's a great contender for interstellar missions. Imagine the possibility of exploring this Earth-like exoplanet. Though we can't travel there yet, it's definitely on the radar for future missions as technology makes it accessible. It's one of the most exciting projects in the field of space exploration. But getting there is no easy feat. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a solution has been proposed: solar sails. These ultra-thin sails could be used to accelerate a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. And you know what's even cooler? This incredible technology has the power to shed light on the possibility of life on other planets like Proxima B. But as with anything this awesome, there are some limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus with a thick, hot atmosphere that's not suitable for life. And get this, the James Webb Telescope has the power to detect such illumination if it reaches a brightness of just 5% of the natural dayside. Now, 5% might not sound like much, but when you're dealing with a star that's 20,000 times dimmer than our own sun, it's actually a huge deal. And if Proxima B does have an intelligent civilization that's lighting up its surface, they may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our very own Earth. But what do we know about them? One type of exoplanet that has captured the attention of astronomers is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed super-Jupiters, and they dwarf even the largest planet in our solar system. But that's not all. There are also hot Jupiters, which are gas giants that orbit extremely close to their host star. They exist in a fiery world with temperatures that could melt metal. Imagine being able to witness such a planet up close, with its raging storms and blistering heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are the hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from afar. And let's not forget about the terrestrial exoplanets, which resemble our own planet Earth. These planets come in various sizes, ranging from smaller than our world to double its radius. There are even super-Earths, which have masses greater than twice that of our planet but lighter than Neptune. One of the most intriguing exoplanets in recent years is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an approximate mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b is not alone. It has a partner in crime, Proxima Centauri c, which is even further away from the star. This planet has an orbital period of approximately 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. But what's even more fascinating about Proxima c is that it appears to be a very bright world, possibly due to the presence of a ring system. And there's still more to discover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary partner. If confirmed, this planet will be known as Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a world where the night sky is filled with not just stars but countless other planets, each with its unique composition and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made all the time, it's an exciting time to be an astronomer. While we don't yet have an accurate count of exoplanets, we do know that they exist, just like we know the stars that light up the cosmos. However, exoplanets are not easily observable, and it requires state-of-the-art technology and powerful telescopes to detect them. These planets are often obscured by the glare of their host stars, making them difficult to study. But with advancements in technology, direct imaging of exoplanets is now possible. To be directly imaged, an exoplanet must be large enough to be seen by the telescope, far enough from its host star not to be obscured by its glare, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the characteristics and composition of these distant worlds. Exoplanets are most commonly discovered through the changes they cause in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are some fun facts. Did you know that over 22% of stars, like the Sun, have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets, like the planets in our solar system, can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know that they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to discover, but there are countless other exoplanets waiting to be found. NASA's James Webb Telescope is unlocking the secrets of the universe one discovery at a time. This remarkable telescope has been gathering information and capturing stunning images of the cosmos, unveiling previously unknown wonders of the universe. Recently, it made history with a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has discovered the first conclusive proof of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides critical information about the planet's composition and evolution, offering us a glimpse into the mysteries of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding is a significant breakthrough in our search for extraterrestrial life. NASA Administrator Bill Nelson promised that this discovery would give us a new perspective on the universe that we've never seen before, sparking excitement among astronomers and researchers around the world. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and gathering information about the cosmos in the infrared. The light from the young, outflowing protostar named 110 IRS-4 illuminates the chilly, wispy cloud material, and the orange dots behind the cloud reveal the light from distant stars absorbed by the ice in the cloud. This magnificent research was part of Webb's Ice Age project, which aims to study the evolution of ice from its creation to the formation of icy comets. And that's not all. The James Webb Space Telescope replicated the inner workings of a dusty disk surrounding a nearby red dwarf star, imaging it for the first time at these light wavelengths in the infrared. This discovery provides crucial insights into the formation of planetary systems and could help us understand how our own solar system was created.